An observation our group made was that during tornado conditions that a home is faced with, the pressure of the surrounding atmosphere often drops lower than the pressure inside the home. This led us to ask the question, during a tornado, could this pressure gradient that is larger inside the home than the atmosphere cause the roof and sidings of the house to bend outward and cause more damage than it otherwise would if the windows were open? Our group's hypothesis is that under reduced pressure conditions caused by a tornado, by opening the windows of a house, the pressure inside the home will equal the pressure of the atmosphere surrounding the home. As you can see in our schematic, this indicates that no pressure will build up inside the house, causing damage and possible blowouts of the windows and the foundation to expand. Our relevant equation in analyzing this is pressure equals force times area. Our thought process is that the net force on the structure from the buildup with closed windows will yield more damage on the house during the tornado conditions than in the open window scenario.
So for the analysis, there are a few assumptions that we made. The first one is the average wind speed in an F5 tornado is around 150 meters per second. Second is air is assumed to be an incompressible fluid. Third, the total area exposed to a tornado is 4 by 4 for each wall, hence 64 meters squared. Number 4, the area of the roof is 20 meters squared. And number 5, each wall has a window of 1 meter squared. And we've already divided the case into two cases. The first is when the windows are closed, and the second is when the windows are open. If the windows are closed, the forces acting on the house due to differential pressure are calculated as follows. This force is calculated to be 1.16 times 10 to the power of 6 Newton. The force acting on the house due to stagnation point of the wind on one of the walls is calculated to be 1.4 times 10 to the power of 6 Newton. This stagnation force is from the tornado to the house, while the differential pressure is from the house towards the tornado. That means these forces will cancel out each other. Hence, the total force acting on the house is 2.34 times 10 to the power of 6 Newton.
For our second case, the windows are open. If the windows are open, the wind from the tornado can come in and blast through the roof and walls. This force is calculated with the equation below. From this equation, we get that it turns out it's 6.98 times 10 to the 6 newtons. There's also a force from the stagnation point of the wind on one side of the wall, which is calculated by that equation below. This can be canceled out some of the forces inside the house, and then the total force of the house can be equal to F equals 5.67 times 10 to the 6 newtons.
In conclusion, if the homeowner opens the wrong window, air can crush him and exert pressure on the structure from the inside like blowing air into a balloon. It is unlikely that the resident knows where the construction weak points are. In addition, the wind fields in the passing tornado are very complex and constantly changing. It is not possible to predict the strongest prediction of attack. The best advice from an engineer is to leave the windows closed and get into a basement or other shelter as fast as possible. Theoretically, opening the windows in both the front and the back of the house will allow air to move through the house and reduce any buildup of interior pressure. But there is no evidence that any opening of windows ever helped to hold the roof in place. The best advice is still to close the windows and get to a shelter.